$43. That's what a mechanic in Albuquerque spent on a single quart of oil from one of the most marketed, shelf-dominant brands at his local auto parts store, the kind with the full-page magazine spreads and the NASCAR sponsorship. 6 weeks later, he was back in the same shop, this time on the other side of the lift, staring at sludge deposits coating his engine's valve cover, like something you'd find in an old frying pan. The brand hadn't changed, the engine had. I've spent the last 11 years digging into the chemistry behind lubricants, not as a brand ambassador, not as a marketer, but as someone who got burned the same way. And what I found when I started pulling API certification documents, cross-referencing base oil sourcing disclosures, and comparing additive package data is something the major oil companies spend considerable money making sure you never think to look for. This isn't about a secret product swap. It's about understanding what you're actually paying for, and why the brand on the bottle tells you almost nothing about what's protecting your engine. Here's what changed. When I stopped buying based on brand recognition and started buying based on what the oil actually is. Most drivers see that API starburst symbol on an oil bottle and assume it's a quality guarantee. It's not. The American Petroleum Institute's certification system is a pass, choice, fail threshold. It confirms that an oil meets minimum performance requirements for a given service category, not that it exceeds them. A store brand oil and a premium priced name brand oil can carry the exact same API SP certification while having dramatically different formulations underneath. Here's the technical reality. The API certification process is paid for by the oil company seeking approval. Labs run standardized engine tests. The sequence IVB for camshaft wear, the sequence 3H for oxidation stability, and if the oil crosses the minimum thresholds, it gets the stamp. There's no published score, no comparative ranking, no disclosure of how far above or below the threshold the product landed. Two oils certified under the same API category can differ by 30% in actual wear protection and oxidation resistance in real-world testing. A fleet manager in Cincinnati switched his 38-truck delivery operation from a nationally advertised brand to a lesser-known oil with an identical API rating, but sourced from a Group 3+ base stock. After 2 full oil change cycles, about 22,000 fleet miles, his shop reported a measurable reduction in cold start metal particle counts in used oil analysis. Same certification, different outcomes. The lesson: don't read the stamp as a quality score. Read what's behind it. A FOSW 30 label means the oil flows like a grade 5 weight at cold temperatures and provides grade 30 protection at operating temperature. What that label does not tell you is how it gets there. And that gap is where major brands quietly cut costs. Viscosity modifiers are polymer additives that allow a single oil to perform across a temperature range. Cheap viscosity modifier packages shear down, meaning they break apart under mechanical stress, faster than premium alternatives. An oil that pours as 5W30 in a fresh bottle can functionally behave like a 5W22 after 4,000 miles of shear stress from your engine's moving parts. Your engine doesn't know the label. It only knows the film thickness actually present between metal surfaces. Some of the most marketed conventional and synthetic blend oils on the market use lower-cost olefin, copolymer viscosity modifiers with high shear sensitivity. Premium formulations use hydrogenated styrene diene or polymethacrylate modifiers that maintain viscosity stability significantly longer through the drain interval. This matters most in high RPM driving, towing, or extended oil change intervals. A school bus driver in Phoenix running an extended 7,500-mile interval on a popular advertised blend oil had a used oil sample analyzed. Viscosity had degraded to below the 30-weight floor before the interval ended. 5. Emapass resolved the issue entirely. 20. Engine oil is made of 2 components, base oil and additive package. The base oil is the majority of what's in the bottle, typically 75 to 85%, and its quality determines the oil's fundamental performance ceiling. Base oils are classified into 5 groups by the API, and the difference between them is substantial. Group I base oils are solvent refined, contain more sulfur and unsaturated hydrocarbons, and oxidize more quickly. Group 2 and Group 2+ are hydroprocessed, cleaner, more stable, better thermal performance. Group 3 is severely hydrocracked, so refined that the API allows it to be labeled synthetic, a classification that's been commercially contested since Mobil's 1999 lawsuit established that hydrocracked Group 3 could legally carry the synthetic designation. Group FIFO, polyalpha olefins, PAO, are true synthetics, purpose-built molecules with exceptional stability. Group V covers everything else, including esters used in high-performance formulations. Here's what's happening with popular brands. A number of heavily marketed full synthetic oils on the US market are Group 3 based, not Group FIFO. That's not illegal. It's not even unusual. But it means that a 13 per quart oil with a trusted name may be offering you the same base stock as a $7 oil from a lesser known brand, with the price difference going to advertising spend rather than formulation quality. A chemical engineer in Portland ran parallel used oil analyses on 3 major synthetic brands after 5,000-mile intervals in identical 2019 Honda Accords used for similar commute patterns. Total base number, TBN depletion, the measure of how much acid neutralizing capacity the oil had consumed, showed a 22% variance across the 3 brands, despite all 3 carrying the same API SP certification. Read the technical data sheets, not the label. The TDS is where the product actually lives. Base oil quality gets the most attention in enthusiast circles, but additive packages are where oil companies make the most consequential decisions, under cost pressure. A full performance additive package includes anti-wear agents, antioxidants, detergents, dispersants, friction modifiers, and corrosion inhibitors. Each of those components has a cost-quality spectrum, and every reformulation is a set of trade-offs. The most critical? ZDDP, zinc dialkyl-dithiophosphate, the primary anti-wear compound in most engine oils. ZDDP levels have been progressively reduced in mainstream API-certified oils since the late 1990s because high zinc concentrations can shorten catalytic converter life. Modern API SP category oils operate at lower ZDDP thresholds than oils from 15 years ago. For high-mileage engines with flat tappet camshafts, worn valve trains, or any pre-2005 pushrod engine, this reduction is a legitimate concern. Those engines were designed around higher zinc oil chemistry. The divergence in real-world performance doesn't show up at 30,000 miles. It shows up at 90,000. And it shows up as wear rates that are 15 to 20% higher in independent tribology studies, comparing low ZEDP to higher ZEDP formulations in pre-emissions era engines. A retired machinist in Knoxville running a 1998 Chevy K1500 with 210,000 miles switched from a nationally advertised full synthetic to a manufacturer-rated ZDDP enhanced oil typically used in diesel and racing applications. His next valve cover inspection, 40,000 miles later, showed noticeably less cam lobe wear than the previous inspection interval. 49 a quart. 10. The difference per oil change, less than $4. When a popular oil brand appears on your vehicle's oil cap or in your owner's manual as the recommended or factory-fill choice, many drivers assume that recommendation emerged from independent performance testing. In most cases, it didn't. It emerged from a commercial licensing agreement. Oil companies pay vehicle manufacturers for co-marketing endorsements. The specific terms vary and aren't always publicly disclosed, but the structure is consistent. The oil brand agrees to use the manufacturer's name and logo in advertising. The manufacturer agrees to list the brand in owner's manual recommendations or co-brand oil caps. What this arrangement does not require is that the licensed brand outperform competitors in actual engine protection for that vehicle. This is why the same 2022 Toyota Camry that lists a specific major brand on the oil cap will run equally well, often better by measurable used oil analysis metrics, on a specification-matched alternative that meets Toyota's own published ILSIC GF6A standard and 0W20 viscosity requirement. The recommendation you can trust is the one in your owner's manual that references an oil standard code. ILSAC GF6 API SP ACEA C3, not a brand name. That code is the engineering specification. The brand name attached to it is the marketing agreement. The 3,000-mile oil change interval is one of the most durable myths in automotive maintenance history. And it persists specifically because it generates repeat oil purchases and service visits. Modern full synthetic oils certified to current API standards are formulated to provide full protection at 7,500 to 10,000 miles under normal driving conditions. Many OEM factory recommendations are 10,000 miles. Several European manufacturers specify 15,000-mile intervals with approved ACEA-rated oils. Here's the conflict of interest. Oil companies make more money when you change oil more often. Quick lube franchises generate revenue per visit, not per mile. The 3,000-mile interval recommendation, still plastered on stickers and windshields across the country, benefits everyone in that supply chain except your wallet and arguably the environment. A logistics analyst in Denver calculated the lifetime oil change cost differential for a vehicle driven 180,000 miles using a 3,000-mile interval versus a 7,500-mile interval with a quality full synthetic. The 3,000-mile approach required 60 oil changes. The 7,500 miles mounted mile approach, 24, at an average DIY cost of $45 per change. The difference was $620 in savings, with used oil analysis confirming the extended interval oil was still within spec at the end of each drain interval. Stop letting marketing intervals dictate your maintenance schedule. Your owner's manual has the correct interval. A $25 used oil analysis kit will confirm whether your specific driving conditions justify extension or shortening of that interval with actual data, not a windshield sticker. This is the fact the industry least wants to talk about. A significant percentage of store brand and private label motor oils sold in the United States are formulated and blended at the same facilities, sometimes from the same base stocks as major branded products. The difference is the label and the marketing budget. Large oil companies operate contract blending operations. They supply base oils to third-party blenders. They blend under private label for large retailers. The certification process, not the brand, determines what ends up in a given bottle. A store brand full synthetic at a major retailer carrying API SP certification and the correct ILSAT grade has passed the same performance threshold as the 14 per quart bottle next to it with the Racing Heritage branding. A mechanical engineering professor at a Midwestern university ran a study comparing rheological properties, viscosity, pour point, flash point, oxidation stability, across 8 motor oils from 5 price tiers. 3 of the private label or value tier oils tested within statistical equivalence to the 2 premium tier oils on every measured parameter. The premium oils cost 62% more per quart on average. None of that means every cheap oil is equivalent to every expensive oil. Formulation quality varies enormously within every price tier. The filter is the specification code, and if you want to go deeper, the technical data sheet. Not the brand heritage and not the price. Most drivers read their owner's manual's oil recommendation as a brand suggestion. It isn't. It's a technical specification. And that specification is your most powerful tool for finding the right oil regardless of marketing. SP, SN+, ILSAT grade, GF6A for OZRW20, 5W20, VOSW30, GF6B for STW16, and for European vehicles, ACA classification, A3, B4, C3, C5. 0. That imposed tighter formulation requirements than generic API certification. When you search for oil using these specification codes rather than brand names, the selection criteria shift entirely. You're filtering by engineering performance, not advertising spend. An oil meeting BMW Long Life 04 approval, for example, must pass a set of manufacturer-conducted engine tests that go well beyond standard API requirements, regardless of what brand name is on the bottle. 50 per quart for the dealership-recommended branded oil. 20 per quart. His last used oil analysis, at 8,500 miles, showed TBN retention and metal particle counts indistinguishable from his previous dealership fill intervals. Annual savings, approximately $140. The specification code is the specification. Learn your vehicle's code. Search by that code. The brand becomes secondary. When most drivers see the word synthetic on an engine oil bottle, they picture molecules engineered from scratch. Polyalpha olefins, purpose-built chemical structures with superior thermal stability and inherent uniformity. That's group IVOR chemistry. It's what synthetic meant before 1999. In 1999, Castrol successfully defended the right to market its Group 3 hydrocracked oil under the synthetic label in a legal dispute with Mobil. The ruling, upheld by the American Petroleum Institute, established that oils refined from petroleum to Group 3 purity standards could be marketed as synthetic. The legal argument was that the refining process transforms the base oil enough to warrant the designation. The counter-argument from chemists is that Group 3 and Group 4 perform differently under extreme conditions, specifically at high temperature oxidation stress and at very low cold temperature pour points, in ways that matter to performance engines and turbochargers. This isn't a hypothetical. Turbochargers operate at shaft temperatures exceeding 1,800 degrees Fahrenheit. Bearing clearances are measured in thousandths of an inch. Post-shutdown oil coking, where oil residue bakes onto turbo-bearing surfaces after the engine stops, is a documented cause of premature turbo failure. Group 4, PAO-based synthetics, resist coking meaningfully, better than Group 3 at equivalent HTHS viscosity grades. If you're driving a turbocharged vehicle, and in 2024, that's the majority of new cars, the distinction between Group 3 synthetic and Group Phi synthetic matters. It won't appear on the label. You have to look at the technical data sheet, find the base oil composition, and verify the chemistry yourself. Or find a brand that publishes its base oil group publicly. Some do, most don't. 2 consecutive used oil analyses, same driving profile, 6,000-mile intervals, mixed highway and urban, ambient temperatures ranging from 28 to 97 degrees Fahrenheit, 99 per quart, 40 per quart. 9 for the alternative. Iron content, the primary indicator of engine wear, was 8 parts per million for the advertised brand, 6 parts per million for the alternative. Copper content, indicative of bearing wear, was statistically identical. Oxidation was lower in the alternative by a margin that surprised me. The alternative protected the engine better by two measurable metrics, 59 less per quart, 75, and the engine showed less wear. I'm not telling you every cheap oil beats every premium brand. That's not what the data shows. What it shows is this: brand recognition and price are not reliable proxies for formulation quality. The specification code, the base oil group, the additive package data, and the used oil analysis results are reliable proxies. The brand name on the label is a marketing investment. What's inside the bottle is a chemistry decision. Check your owner's manual for the specification code your vehicle requires. Pull the technical data sheet for the oil you're currently using. It's publicly available for any reputable oil, usually on the manufacturer's website. Find the base oil group, find the HTHS viscosity, find the TBN, compare those numbers across 3 or 4 brands at different price points. What you'll discover is that some of the most expensive oils on the shelf are buying you a logo, not better protection. The mechanics who do their own oil analysis, the fleet managers running cost per mile calculations, the engineers who read data sheets instead of ad copy, they've known this for years. Your engine doesn't care about the brand. It cares about the film strength under load, the oxidation resistance at temperature, the wear protection at startup. Those things live in the formulation. Find the formulation. Let the brand name come second. What's in your oil right now? Pull out the bottle and look up the technical data sheet. You might be surprised what you find, or what you can't find, which is information in itself.